The next property that we're going to look at is the quotient property of radical expressions. So this is similar to what we did earlier, except that instead of multiplying, we're going to divide. So let's say, for example, in the first one, square root of 15 over 64 can be broken down into square root of 15 over the square root of 64. But we know that 15 is not a perfect square. See? It's not in the second column. So we're going to keep square root of 15 inside the radical symbol all over. Now the square root of 64, we know 64 is a perfect square, is 8. So that's going to be your final answer. That was easy, huh? Okay, let's try again. Square root of 81 over x squared. So let's break it apart. Square root of 81 over square root of x squared. And we know that both of these are perfect squares. The square root of 81 is 9, and the square root of x squared is x. So that's the final answer. Now, let's see. I got more examples after this. Let's try the next slide. Here we go. Alright. So for the first one, again, distribute the radical sign. So 23 over square root of 9. 23 is not a perfect square. So just copy it down. And then the square root of 9 is 3. Alright. I hope you're getting this so far. Next, what if it has a negative sign? So negative square root of 17 over square root of 100. So negative square root of 17, that's not a perfect square, over the square root of 100 is 10. You know, once you get the hang of it, you can actually skip the part where I'm just rewriting it as a quotient of two numbers. So, example here in the third one, if you can already see that, oh yeah, radical 36 is 6. So you can just write down the answer. And then square root of z squared, oh, I know, that's z, and you're done. So I was just showing this part earlier because, you know, I didn't want to lose anybody, so I'm trying to write down all the necessary steps. Okay, for this one, so square root of 4, no, I should break this down because there's this is a different type of example. So square root of 4 and then square root of x squared, right? And then 64 goes to the bottom. There you go. So square root of 4 is 2. Square root of x squared is x. And then the square root of 64 is 8, right? But you don't stop there. Why? Because you know that 2 and 8 can still be simplified. But remember, you're not getting the square root anymore. You're just simplifying like a regular fraction. So you can divide both of them by 2, right? So they can cancel out when you divide each by 2. So you get x on top and then 4 at the bottom. So going back to the original problem, you can actually simplify from here before you get the square root. So if you can divide 4 by 4 first, that will turn into 1. And then divide this by 4, and you will get 16, right? The square root of 16 is actually 4. So for this type of question, you can do it in two ways. You can break it down. If you're not very comfortable with, you know, simplifying the 4 and 64 together under the radical sign, or you can do the shortcut. You can divide 4 by 4, 16 by 4, and 64 divided by 4 is 16. And from there, you can get the square root. So the square root of x squared will still be x, and then the square root of 16 is equal to 4. So those are two possible methods. Let me see if I have some more. Okay, so in the next video later on, we're going to look at how to simplify cube roots.